All right, welcome to the ending of 6.5. So we are going to continue using those skills, especially the last one, where we take the complex number to a power. We're going to use that today to figure out the solutions to our complex problem. And so basically we're just going to set it equal to 0. And we will be using the theorems we talked about yesterday. So, just to review a little bit, this is our main friend. Am I spelling that correctly? I don't care. And this is his buddy Newton. So they were very good friends, proving stuff in math and physics. They look a little scary, but let's remember it was a different time. Let's jump in here with some review problems. So the first one is to rewrite in polar form. So right now it is in rectangular. And so my point would be -1√3. So the first step is to plot that. So that's going to be in quadrant 2. Negative, positive. All right, our next step is to solve for our radius. So that would be 1 squared plus √3 squared, which is just going to be a radius of 2. 1 plus 3 is 4. My next step is to solve for my tangent. Tangent is y over x. So that's going to be √3 over -1, which is just -√3. So let's look in quadrant 2 for -√3. What angle gives me -√3? I think it's 120, but double check me. I don't even have my paper out. I'm not even ready for this. It is 120. So my angle is 120. And so to rewrite this in polar form would be 2 CIS 120. Or if you wanted to write it the long way, it would be 2 cosine of 120 plus 2I sine of 120. So either is acceptable there. Let's move on to number 2. So we're using the theorem here, the exponent theorem. So it's in polar, so I can go right ahead and use the theorem. And it tells me to take the exponent to the, take the exponent, the radius to the exponent, so 3 cubed, and then I multiply the exponent to my angle. 3 cubed I sine of 3 times 80 degrees. So let's simplify this a little bit. That would give me 3 cubed is 27. 3 times 80 is 240. Awesome. That's on the unit circle. All right, so let's look that up on the unit circle. The x-coordinate, the cosine is -1/2. We are in quadrant 3. And so this one would be -√3 over 2. Alrighty. The reason I'm doing this is because it does tell me to write it in a plus bi form. So that means I do have to substitute my values for cosine and sine. So multiplying, this is just 27 over 1. So this would be -27 over 2 plus -27I√3 over 2. So I'm just putting that over 1, so my denominator is just 2, and my numerator you just multiply across. 27 times negative 1, 27I times negative root 3. Great, so those are our warm-ups. We will be using these skills as we go along. Let's jump into what we're doing today. So we're finding the roots. The roots are another word for x-intercepts. So basically, we're setting our problems equal to 0, right? We're figuring out what x values give me an output or a y value of 0. So if you were to graph these and look up your intercepts, that would be another way to accomplish what we're doing here. So let's get started here. A lot of the properties that we learned yesterday will apply again today. So for example, the first step is always going to rewrite the problem in polar. So that means r's and thetas, not x's and y's. The next thing you're going to do, if I'm finding a root, if I'm finding a square root, that means I'm taking, right, the square root, a cube root, a fourth root, but in any case, I'm getting an exponent, right? Do you know that the square root is the same thing as a power of 1/2? The cube root is the same thing as a power of 1/3. The fourth root is the same thing as a power of 1/4. So that's where the exponent, not cosine. This is where the exponent theorem from yesterday is going to come in handy. So 1 over n, right? Well, that's going to be r to the 1 over n power, and then it's just going to be my angle times 1 over n. That's what we're going to end up doing. So that's going to give us one answer, but then I'm going to need to add my new, add to get to my next solution. So you're going to write your first answer, which will we'll get there, and then we have to add, basically think about it as adding your new period, right? So if I have, if I'm taking an nth root, if I'm taking a square root, then I have two answers, right? If I'm taking a cube root, then I'm multiplying something by 3 times. If I'm getting a fourth root, I want 4 answers. So you'll have as many solutions as your n. So square root, you'll have 2 solutions. Cube root, you'll have 3 solutions. Fourth root, you'll have 4 solutions. So to get all of your solutions, we have to add 360 divided by n. So I'm taking my period and I'm splitting it up into how many answers I want. And then your final answer should be in standard rectangular form. So it should be in x plus yi. So you are going to have to change it at the end, just like we did in the warm-up. That's why I had us do that. So you are going to have to do this step. Now this is a lot of information, but I promise it will make more sense when we put it all together. And just skip that part right there. Yes, last try. Let's see this in action. So find the complex. That means I might be invited. Cube root. That means n equals 3. I'm going to have 3 solutions of -1 plus root 3i. Calculate both polar and standard form. A plus bi is the same thing as x plus yi. Keep argument in degrees. All right, let's follow my steps. Step 1, rewrite the problem in polar. All righty, let's do it. Rewrite this junk in polar. So it's -1 root 3, calculating in polar. You plot it, you figure out your r. Remember, when you square it, the negatives don't matter. I just leave them out. Then it's the tangent is y over x. So that would be -root 3. And I believe that my angle is, what do you know? Isn't this just our warm-up? It's all coming together. So my angle is 120. So in polar, it would be 2 CIS 120. Perfect. That is converted into polar. Step 2 is to apply my theorem. Okay, so I'm taking this and I want to take it to what power? Well, I want the third root, right? So I'm taking it to the 1/3 power. So then that becomes 2 to the 1/3 times CIS 120 times 1/3, which is just, we can write this as the cube root of 2 CIS 120 divided by 3, that's just 40 degrees. So I've applied the theorem. Write down your first answer. So this is your first answer. Root 3, 2, CIS 40 degrees. Now, to figure out what that is in rectangular, we'll get to that in just a moment. Let's figure out the rest of my answers. So the rest of your answers will have the same radius. The only thing that's going to change is the angle. So if you want to just fill that in. Now we just have to figure out what am I adding to this angle here. And it's just 360 divided by n. N is 3. So 360 divided by 3, that is just 120. So I'm on this step here if you're following along. So I'm adding 120 to my angle. So 40 plus 120, that would give me 160. 160 plus 120, that would give me 280. Yay, I'm done. All right, let's get this in rectangular form. So to do that, I want to, oh, no, I don't want that. I need my calculator. Where did it go? Finder. Get out your calculator while I'm searching for mine. Here it is. So I'm just going to go over how to put roots in your calculator just in case you forgot. All right, come on, calculator. All right, sorry about that. So we should be in degree mode since my angle there is in degrees. I'm in radians, so I better double check. Degree. Awesome. All right, so to do a root, if I have the cube root of 2, that's just 2 caret 1 divided by 3. So that's what I want to put in. And now I'm just multiplying. My first one was an angle of 40 degrees, so I'm multiplying it by 40. And that gives me about 0.97. 0.97 is my real component. Now I need to figure out my imaginary. So if you wanted to write this out, it would be the cosine of 40 plus the cube root of 2 I sine of 40. Okay, so now I have to figure out what is 3 root 2, the cube root of 3, times the sine. So 2 to the 1/3 power, and then multiplying it by the sine of 40 degrees. This is very tedious, I agree, and it's 0.81. 0.81i. So this is it in rectangular, this is it in polar. So with my time left here, fill in the rest of these, and I'll start again with the next video to finish the examples.